together with the probabilities. Then what you have here is what we call the probability distribution of our variable. What is the expected value of the expense forecast for the coming year? The expense forecast, the expected value is given by this formula here is the sum of x, fx. So in other words, if you just take each value of x multiplied with the probability, and then you sum everything together, and then you have the expected value. So here we have 9, 0.3, 10, 0.2, etc. And then we have the sum here. Okay, so the sum here is $10.56 million. Okay. It's not 10.56, it should be 10.69. 65. All right. Okay, so this is the question B. For question C, very simple. We also have the formula to calculate the variance by taking the sum of x minus mu square multiplied with the probabilities. And remember that the mean here is actually the expected value. So expected value here is actually the long-term average. Okay. So we can just take each of these values here. X, for example, 9 minus mu here, which is 10.65 square multiplied with the probability. And then you just do the same here. Okay. If the income projection for the year are estimated at 12 million, comment on the financial position of the college. So from what we have here, we have the expected incomes is actually at $12 million. And then we have the expected expense. We calculate in part A as 10.65 million. So if you take the difference between the incomes and the expenses here, you can see that obviously what the college earns is actually higher than what it has to spend for the coming year. So I must say that the financial position of this college is quite good, because what you earn is actually higher than what you have to spend. But of course, this is just projection, not the actual value. Okay. But from the projection here, the financial position of the college here is quite good. Okay. So this should be the answer for these questions. I will go through the exercises, and if you have any questions, don't hesitate to to ask me if you have anything that you are unclear. Okay. Now for question 8, we have the unemployment rate. Here is 4.1%. We assume that we have 100 people. And then you have to calculate the expected number of people who are unemployed, the variance and the standard deviation here. All right, so for this question here, we have to prove that what we have here is the binomial distribution. All right, so remember that there are 4 requirements for distribution to be binomial. The first one is we have 2 outcomes. So when we survey a person and ask for their employment status, the person is either unemployed or employed. So there are two possible outcomes here. The person is unemployed or the person is unemployed. So that is the first requirement. The second requirement is the probability of unemployment is the same because here we have 4.1%, which is the fixed value. Then the next requirement here is we have N trials. Here in this situation, we surveyed 100 people. So N here in this situation is equal to 100. And then we have independent trial, meaning that the employment status of one person doesn't influence the employment status of the other person. So after all of the requirements for the binomial distribution are satisfied, then now we can use the binomial distribution in order to answer these questions. So we can just write out here this one P and this one here is N. For all of these exercises, I suggest that you write out things in notation so that it will be easier for us to look up for the correct formula. So the expected number of people here is equal to NP. So we have 4.1% multiplied with 100. So we have 4.1 people. So on average, we expect that 4.1 people will be unemployed. The variance, we can just use the variance formula for binomial distribution, which is quite simple here. So we have 4.1%. Then we have 95.9%. And we have 100. Okay, so you can just have the answers here. And then as for the standard deviation, we can just take the square root of the variance. And then you got the answers. Okay. So I'll just give you the idea of how you are going to do the exercise. As for the the final results, you can just calculate them by yourself. Okay. But basically, this is the formula. All you need to do is just to multiply everything together and take the square root of the values, and then you have the standard deviation. Okay. Any questions so far, class?
No.
All right, so let's move on to the next exercise. All right, so just remember that for tutorial number 4, we studied two different types of random variables. The first one is discrete random variable, and the second one is the continuous random variable. For discrete random variable, we have the probability distribution, and one special probability distribution for discrete random variable is actually the binomial distribution. From exercise 9 onwards, what we are dealing with is the distribution for continuous random variable. And one very special continuous random variable distribution is the normal distribution, which is this one here. All right, so for exercise number 9, what we have here is a standard normal random variable. And before we go any further, I'll just list out some of the ideas about the standard normal variable here. Now, if this is the distribution for Z, this is the standard normal distribution. So for Z, the median is actually the same as the merge and the same as the mean. So if we denote the mean here, is the point that goes from the highest point to the center of the graph, then this value here is the mean and is actually equal to 0. The standard deviation or the standard normal distribution is 1. And for this, we have bell-shaped distribution. So it has the shape of the bell. And for bell-shaped distribution, the distribution is always symmetric, meaning that when we draw a line from the highest point of the graph to the center here, to the mean here, then that line will divide the graph into 2 equal halves. So we have 0.5 here, 0.5 here, because the whole area here is 1. Okay. All right, so that those are some of the ideas about the standard normal distribution. Okay. All right, so now what we are going to do is to use the Z table in order to find the probabilities. And in order to use the Z table here, there are something that I should tell you. Now, whenever you are asked to find the probability of Z smaller than some value, you can just directly look up the Z table for this. Okay. If the question asks you to find the probability that Z is greater than something like this, then the idea here is we can easily convert the probability here in the probability that we can look up the tables. So instead of having a greater sign here, we change it into smaller signs. Okay. And for these values here, if you see that is the negative value, please change it into a positive value. If it's a positive value, then you can convert it into a negative value. So for this, we can easily change it into this. Okay. So you change the direction of the sign and you change the sign of the value. Okay. The reason why we can do it is because that distribution is actually symmetric. So for example, the probabilities here and the probability here, these 2 areas here must be the same. Okay. So we can easily convert this into something like this. Similarly, when Z is greater or equal to minus 1.5, we can easily convert it into a smaller one and change the sign, which is 1.5 here. Okay. And then you can just do the same for this. Okay. P smaller or equal. And then we change the sign here from negative to positive and vice versa. And when you're asked to find the probability that Z will be between these 2 values, then you take the probability that Z with the larger values minus a smaller value. Okay, so this is how you are going to find the probabilities from the Z table. But just be careful, okay? If you search the internet, then you will see that there are a lot of different kinds of Z table. So what we are going to do here is just to use the tables given in our textbook. If you use the tables given on the internet, the way that you find the probability might be different. Okay. Now, the reason why we have to do find the probability like this is because if you look at this one here, if you look at the table here for Z distribution, then you will see that for this uh, the the Z table here will give you the area to the left of Z. So it means that here it gives you the area here. So this table only give you the area that Z will be smaller or equal to some value. Okay. Can I calculate it by taking 1 minus? Yes, of course. Okay, so if you have Z, greater than, okay, I'm just show you how to do that later. Okay. All right. Okay, so let's do some of the questions together. So for question A, for example, you have to find P of Z smaller than minus 1. So all you need to do here is just to look up the table because you have P of Z smaller than something already. Okay. All right. So, okay. So all you need to do here is just to look up the value of minus 1 here in this table. So we have minus 1 here. Okay. Now remember that the first column here for Z give you the whole number as well as the first decimal value, and the row here give you the second decimal values of the Z. So here, minus 1 here is minus 1.00. So the values that we are looking for here is this value here, 0.1587. So I just write out here 0.1587. For question B, P of Z greater or equal minus 1. So you can just do it in two ways. You can just turn it directly into Z smaller or equal 1. Okay. Or you can just take 1 minus P of Z smaller than minus 1. Okay. If that is what your lecturer told you. But to be honest, if you do it the second way like this, it will be more time consuming because you have to take the 1 minus the previous value here, which is equal to 1 minus 0.1587. Okay, and then you have to calculate this value. But if you look up directly for this value, you do not have to do any calculation at all. So here we have P of Z smaller than 1. So we just look at the value of 1 here. And here we have directly this value, 0.8413. And I just write out here 0.8413. Okay, the same thing here. Okay, so whatever you do, you will just have the same results. But I think that it will be a little bit quicker if you just change the direction here, change the direction and change the signs of the value, and then you got the answers. Okay. Okay. So Twin, does this answer your question? Okay. All right. So that's it. I think that for the remaining values, you can just do it by yourself. So maybe we can just do one more thing. P Z greater or equal minus 1.5 will be equal to P of Z smaller or equal 1.5. So we just look at 1.5 here. 1.5 here. So you do not have to do any calculation. Just take this value from this table here. So we have 0.9332. Okay, directly from the table. All right, now class, for question D and E, please give me the answer for these two questions. Okay, and please type all the answers onto the chat box. All of you are required to send me the values. Okay, D and E. You do not have to write out the way to do it. Just give me the value. Okay. All right. So I'm just writing out the answers here. So we have 0.9938 and we have 0.4987. Okay. All right, so that's it about this exercise. Let's move on to the second, to the exercise number 10 here. Now, for exercise number 10, to be honest, it is exactly the opposite of what you have for exercise number 9. For exercise number 9, you are given the the Z value, and then you have to find the probability. But for exercise number 10, you are given the probability, and then you have to find the Z value. So exercise number 9 and exercise number 10 are actually the reverse of each other. Okay. So let's see how we can do this kind of exercise here. Okay. So given that Z here is a standard normal random variable, find Z for the following situation. The area to the left of Z is this value. So for this specific value, I suggest that you draw the graph for this. This will be easier. So for example, for question A here, we can just draw the graph here. And because this is that, the center value here is 0. Okay. And then, the area to the left of Z here is only 0.2. Remember that for Z value, the area here to the left here and to the right here is 0.5. So here in this situation, we have the area to the left is 0.2, which is smaller than 0.5. So Z here should be somewhere around this here, Z here, such that the area to the left of Z here is actually equal to 0.2119. Okay. All right. Okay, so this is how we define Z here. So if you are given the area to the left, you can just directly look at the table, because the table gives you the area to the left, right? So you can easily look up the table for this. All right. Next. We have the area between minus Z and Z. Okay, so here if we draw the graph here. Okay, we have minus Z. We have Z here. Okay, and we know that the area here is 0.9030. So the idea here is whenever you are asked to find the probability or the value of Z, we have to convert it into the area to the left. Now you have the area, in between these two values. So what is the area to the left of the value? So we can easily identify from this. Remember that, the Z distribution here is symmetric. So these two area here and these two area here must be the same. So we can easily find the probability to the right here, which is equal to 0.903 divided by 2. So we have 4515 here. Okay. And then now you have to find the area to the left here, right? The whole area to the left here. So remember that half of this will be equal to 0, which is 0.5, sorry. Okay. So you can easily find the whole area here, which is equal to 0.5 plus 0.4515 or 0.9515. Okay. Now, as for the area next, for question C here, the area between Z minus Z and Z here, it should be easy, okay, because it will be the same as B. So I'll just ignore this. The area to the left in question D, also very easy. The area to the right. Okay. Now, as for the area to the right here, remember that, here, we know that, the area to the right here, this is 0, this is Z, and the area to the right here is 0.6915. And we know that the whole area here is 1. So we can easily find the area to the left here, which is equal to 1 minus 0.6915. And this will be equal to 0.580. Okay, this value here. Remember that, for the Z distribution, and if you are using the table in the textbook, you always have to convert, into the area to the left, because the table only give you the area to the left. Okay. All right. So all you need to do now is just to look up for these values here. We have 0.2119. We have 0.9515. And we have 0.3085. Okay, we can just look up this value in the table, and now we can just do it. I will show how you are going to do this. Now, in question 9, you are given that value. And then you have to find the probability. So first, you look at the Z value in the first column and the first row, and then you find the probability within this table here. Okay. Now the activity is reversed. You are given the probability in this table, and then you have to find that. So first, our values here is given as 0.2119. So we need to find the value of 0.2119 here in our table. So you just move along here until you see here 0.2119. So once you find this, you can just move along that table to find this value here, and move up here to find the second decimal values. So here the second decimal value is 0, and here the values that we are looking for here is minus 0.8. Okay, so this is how you find this value. Similarly, for question B, we have 0.9515. So we need to find, this value within the tables here. Okay. So for example, 0.9515. And just find 0.5915. Okay, here. Okay. So from this, we can, after you find the probabilities here, you move along here to find this. Okay. And then you move up to find the second decimal value. So here we have the value of Z, which is equivalent to 0.5915. Here is 1.66. Okay. And similarly, for the last case, when you have 0.3085, I think, right, we can just find out this value here, 0.3085. Here, this. So we can just have here Z equal to minus 0.5. So this is how you find the Z value given our table. Any questions for these two exercises? Right. So no question, right? Okay, just remember that finding probability using Z and find Z using probability is very important in our course because later you'll study confidence interval, you'll study hypothesis testing, and all of this require you to find the probability given Z or the Z given probability. Okay. And the normal distribution is the single most important distribution of our whole course. So just make sure that you know how to do this, two exercises. All right, so let's move on to exercise number 11. For exercise number 11 here, we are given the information. Yeah. We have the terms are normally distributed. We have the population mean. We are given the population standard deviation. So whenever we have this kind of question, I suggest that you know write out the information in notation. So for example, the population mean here is mu, so it is equal to 77. The standard deviation here is sigma, so it's equal to 20. And if we can denote x here as the number of hours logged onto the internet, we can now use x here in place of the whole phrase. So what is the probability that a randomly selected worker spend fewer than 50 hours? So it means that x smaller than 50. Okay. So just remember that x here is actually normally distributed. Okay. And whenever a variable is randomly, is normally distributed, we can convert it into a standard normal distribution. And the reason why we have to convert it into a standard normal distribution is to look up the table. Otherwise, it is impossible for us to find the probability. So we can convert x into z using the formula x minus mu divided by sigma. Okay. So from this, we can convert, firstly, we convert x into z, and then we take value x equal to 50. Mu here is equal to 77, and sigma here is 20. So from this, we can find p of z smaller than minus 1 point something, I think. 1.35. Okay, and now you can just look up the table for this value because that is p of z smaller than something. So just look up this table. Okay. For question B, what is the percentage of workers spend more than 100 hours? We'll just do the same. Okay, we convert 100 here into z. So we have p of z greater than 1.15. And then from this, we can convert it into z smaller than. And because the 1.15 here is positive, we change the sign into a negative value. And then look up the table. A person is classified as a heavy user if he or she is in the upper 20% of usage. Okay, so what does it mean by upper 20% of usage here? Remember that our distribution here is normal. The upper 20% here means that these are the area to the right here must be equal to 0.2 or 20%. The upper 20% means that the area to the right here is 20%. Now, if this is a Z distribution and the area to the right here, we can easily find the area to the left here is 0.8. So from this, we can easily find the value of z, given that the area to the left of z here is 0.8. Okay, so we can just look up this table here. So, okay. All you need to do is to find the value of the area, the probability that is equal to 0.8. So we'll just move along here until we see 0.8. Now just remember that sometimes we cannot find the exact value of 0.8 as a probability. So we won't find the value that is closest to 0.8. If we cannot find the exact exact value, we can find the value that is closest to this. So for example, here the values here 0.7995 here is actually the closest to 0.8. So it's okay. So we'll just move along here 0.8, and then we move up here. So z value here is equal to 0.84. Okay. So that should give us the value of z. Okay. So if we go back to our tutorial here, z here is equal to 0.84. But now we have to find the number of hours, which is the value of zx. So we can easily find this using this formula here. So we know that z is equal to 0.84, x is unknown, mu is 77, and sigma here is 20. And from this, we can easily find x equal to 93.8. Okay. So actually, these values here is 93.8. So how the question is, how many hours did a worker have to be logged onto the internet to be considered a heavy user? So the cutoff point here is $93.8 annual hours. So actually the answer here is actually greater or equal to 93.8. Okay. As long as the number of hours here is at least 93.8 hours, then the user is classified as a heavy user. Okay. So these are the answer for question 11. Questions? Got any questions?
Cô ơi, em tưởng là mình phải lấy ở cái giá trị ở giữa 0.04 với 0.05 nữa. Thì Z sẽ bằng 0.845.
Okay, I understand your question here. Okay. Now let me show you the graph again. Now here, here her question is, we have to take the average of these two values, right? But now we won't do the average of these two values if they are, the same in a distance to the value that we want. So for example here, if 0.8023 here has the same distance to 0.8 as what we have here is 0.7995, then we'll take the average of 0.84 and 0.85, and then we have 0.845. But here in this situation, the closest value to 0.8 here is actually 0.7995. So we'll just take this value directly. Okay. Ở đây con nói đến về một chút xíu nhá. Đó là chúng ta sẽ lấy giá trị trung bình khi nào mà ví dụ như cái mà chúng ta tìm ở đây là 0.8, thì chúng ta sẽ ưu tiên nhất là chúng ta tìm những cái giá trị ở trong này mà nó sẽ gần nhất với giá trị 0.8. Còn nếu cả hai giá trị đấy nó gần như nhau, nó đều cách cái giá trị 0.8 này một khoảng như nhau, thì chúng ta sẽ lấy giá trị trung bình cả hai giá trị đấy. Như trong trường hợp mà lúc nãy bạn ấy vừa hỏi. Okay. All right. Okay. So does this answer your question?
Yes.
Okay. So we have here 93.8. Okay. All right. So for question 12, I think that the same questions actually. So first, we have to denote X here as the time needed to complete a final examination in a particular college course. And we know that X here is normally distributed. The mean here is actually equal to 80 minutes. The standard deviation is equal to 10. And for question A, we have to find the probability that completing the exam in 1 hour or less. Just be careful, okay? What we have here is 1 hour, and the information we have here in our question is in minutes. So it just means that we have to find the probability that X is less than or equal to 60 minutes or 1 hour. So just very simple. We just convert X into Z. And then we convert this value into Z as well. So we have 80, 10. So that should give us Z smaller or equal to -2, I think. Okay. So you can just look up the table for this value. For question B, what is the probability that student will complete the exam in more than 60 but less than 75? So 60 smaller than X, smaller than 75. And now we can convert it. 60 is equivalent to -2. So all you need to do is to convert 75 into Z. So it's 0, 10. So basically -2 Z minus 0.5. Yep. So for this, you can just take Z smaller than minus 0.5 minus P of Z smaller than -2. And for these two probabilities, you can easily look up the table. And then from this, you can find the values. And as for question C, now assume that the class has 60 students and the examination period is 90 minutes in length. How many students do you expect will be unable to complete the exam? Okay. So the exam period is 90 minutes. So unable to complete the exam means that the completion time is more than 90 minutes. So basically, all you need to do is to find P of X greater than 90. So Z greater than 90 minus 80, 10. What we have here is P of Z greater than 1. Okay. So for P of Z greater than 1, we can convert it into P of Z smaller than -1. We change the direction and we change the sign here. Okay. And actually, this value here is equal to 0.1587, if you remember, because this is something that you do in exercise number 9. Okay. So once you find the probability here, the question, how many students do you expect? So the number of students in this class is 60. And then 15% of the students will be unable to complete the exam. So what we have here is just to take 0.1587 multiply with 60. And then you have something like 9 point something. I think that it should be 9.5. So the answer to this question is either 9 or 10 students. Okay. So for this question here, we have to okay, when you have to specify the number of students, do you expect will be unable to complete the exams here? I suggest that it's 9 or 10. Okay. Any questions, class?
No question.
All right, so let's move on to exercise for tutorial 5. All right, so for tutorial number 5 here, you will see that we have a finite populations, and we have 5 elements labeled A, B, C, D, and E. We have 10 possible simple random samples of size 2 can be selected. Okay, so we have a populations of 5 elements, and now you have to first select 2 elements out of 5 as our random sample. So for question A, we have to list 10 samples. Okay, so that should be easy, right? So we have AB, AC, AD, AE. Then for B, we have BC, BD, BE. For C, we have CG, CE, and for D, we have DE. Okay, so those are the 10 possible random sample of size 2. Now, using the sampling, simple random sampling, what is the probability that each sample of size 2 is selected? Remember that whenever we use a simple random sampling approach, the probability of each sample must be the same. And in total, we have 10 different samples, so the probability here is 1 over 10. Now, assume random number 1 correspond to A, 2 for B, etc. So I just write out here 1, 2, 3, 4, and 5. So this is the standard way of choosing a sample out of the population using the simple random sampling approach. First, we have the list of the elements in our populations. Then we give them a number, and then we use computer to generate random numbers. So that and based on the random numbers, we can choose our sample. So let's suppose that the computer generates these random numbers here. So we are going to base on this random number in order to select a sample of 2 elements. So the first random number here is number 8, but we do not have 8 here. So we just eliminate this. We also do not have 0. We have 5, which is equal to E here. Okay. We do not have 7. E has been selected, so we'll just ignore this. And for number 3 here, we have C here. And we will eliminate the last one because we have already got 2 elements here. So the random sample of size 2 that can be selected from this random digits here is are C and E. Okay, so that is the answer for these questions. The next question here is, we have a population with a mean of 200, standard deviation of 50. So this is population mean. So we have mu here equal to 200 and sigma here equal to 50. We select a random sample size 100. So here is a sample size 100. What is the expected values of X bar K? The expected values of X bar, you can just write here, is equivalent to the mean, okay? Or in this case, equal to 200. The standard deviation of X bar, sigma X bar, is equal to sigma divided by square root of n. So here our sigma value is 50, and here we have 100 here, so 5. Now we have to show the sampling distribution of X bar. Now the sampling distribution of X bar here, now we have 2 possible scenarios. If our population data is normally distributed, then our X bar is also normally distributed. If in the question it doesn't say anything, then we have to prove that X bar here is normally distributed by using the central limit theorem. Now the central limit theorem states that if our sample size is at least 30, then regardless of the distribution of our population, X bar is approximately normally distributed. Okay, and then here we have X bar where has the expected values of 200, and the standard deviation of X bar here is 5. Okay, so this is how you show the sampling distribution of X bar. You show that it is normally distributed with the mean of 200 and the standard deviation of 5. Okay. And this is according to the central limit theorem. The central limit theorem suggests that whenever the sample size is at least 30, then the X bar is approximately normally distributed. What does the sampling distribution of X bar show? The sampling distribution of X bar is actually the probability distribution of all the possible value of X bar calculated from sample of size 100. So what does it mean by this? This is a theoretical question. So what does it mean? It means that if we have a population, and from the population here we select random sample of size 100 of the same size, and then we calculate the values of X bar from each of this sample here. Then the sampling distribution of X bar is actually the list of all the possible values that X bar can take along with the probability. Or in other words, it shows the probability distribution of all the possible values of X bar given that we take the sample of the same size. Okay. In this case, the size is 100. Okay. So these are the answer for these first two questions. Any questions, class? Any questions? Class, any questions?
No, teacher.
Right, so let's move on to the next exercise. All right, so for question 3 here, we have the mean annual cost of automobile insurance, and we have the standard deviation as well. Okay, so here we have mu equal to 939, and standard deviation is 245. Now, what is the probability that a simple random sample of automobile insurance policy will have a sample mean within $25 of the population mean for each of the following sample size? Okay, so we have 4 different sample size here, and I will show you how you are going to do with sign 30 first, and then we can continue with the remaining sample size. All right, so just be careful with the word within here. Whenever you see the word, within $25 of the population means, it means that, it will take the population mean minus 25 and the population mean plus 25. So within 25 here means that, we have to add and subtract 25 here from the population mean. So, okay, so we have to find the probability that x will be x bar, the sample mean, will be within mu minus 25 and mu plus 25. So, just for, the same for other questions. Now, remember that here in this situation, we have n equal to 30 is the largest. So is the smallest, so we can use the central limit theorem. And we say that x bar here is actually approximately normal. So once you use the central limit theorem to say that, okay, our given sample size here is at least 30. So the sampling distribution of X bar is approximately normal. So after we can prove this, we can use that in order to standardize X bar. So we take the formula sigma over square root of n here to standardize the value of X bar so that we can look up the table. Okay. So from this, we can easily convert it into mu minus 25 minus mu sigma square root of n smaller than z smaller than mu plus 25 minus 25 sigma square root of n. So we can eliminate the same values here. And then what we have here when we talk about within 25 is minus 25 here, sigma square root of n, and plus 25 here, sigma square root of n. All right, so after we can do this, we want just take individual case here. We have n equal to 30. So this will become p of minus 25, 245 square root of 30, smaller than that, smaller than 25, 245 square root of 30. And now you can find the values. For the remaining sample size, you just do the same, and then I will just do the case when we have n equal to 400 here. Minus 25, 245, square root of 400. The only thing that changes here is the value n. 245, square root of 400. Okay. So I'm just write out the answers here. Okay, so I'll just write out the answers here. So we have 0.4246 here, and we have 0.9586 here. You can do the same for the case when n equal to 50 and 100. Okay. So the idea here is for question B, what is the advantage of the larger sample size? You can see from here that when we increase our sample size from 30 to 400, the probability has been almost double from 42% to 96%. Okay, so you can see from here that when we have larger sample size, it means that we have more information about the population. Just imagine that our university has 10,000 students. So if we only survey 30 students, and when we survey 400 students, obviously 400 students will give you more information about our university than only 30 students. So in this case here, the larger sample size increase the preciseness, increase the correctness, and it will result in the higher probability here. Okay. So the advantage of the larger sample size is an increase in preciseness. Our estimation will be more correct, will be more precise. Okay. Right, so that should give us the answer for question 3. Any questions, class? Okay, no questions, right? Okay, if you don't have any questions, we'll just move on to the next question here. So question number 4 here. We have the survey and we have the mean annual salary for male and female. So I just write out here mu male here is actually the mean salary for male, and mu f here is the mean salary for female. Then we have the standard deviation for male is for 40,000, and for female is 25,000. Okay. So the question here is, what is the probability that a simple random sample of 40 will provide a sample mean within? Okay. That is for male, and then we have for female, again 40 females, and a sample mean within 10,000 also. All right, so in order to find this, now just remember that we have to prove that x bar here is approximately normal. The sample mean is normal, so we have here n equal to 40. N equal to 40 is actually greater than 30. So according to the central limit theorem, the x bar for male here is approximately normal. Remember that you have to prove that x bar is normal in order for us to use the z value. Okay. So the probability that x bar for male will be within mu minus 10,000 and mu plus 10,000 will be equivalent to p minus 10,000 divided by sigma. Remember that the formula here, x bar minus mu sigma square root of n. We have 40,000 here, 40. And then we have z here, and we have 10,000, 40,000, square root of 40. Now in the exam, do not just write 10K like this. I write here because I do not have enough space in order to write out everything here. But in the exam, do not write something like this. Okay. So from this, you can find P of Z between these two values. So it should be minus 1.58 and 1.58. And then you can just find the probability here. Okay, we have this value here is equal to 0.8858. Okay. Now you can just do the same for females. Okay. So again, we have to prove that x bar from female here is normally distributed. So we say n here is equal to 40, greater than 30. So x bar for female is approximately, okay. And then from this, we can find the probability that mu minus 10K x bar female smaller than mu plus 10K. Okay. So the same thing happens here. We have P minus 10,000, 25,000. Okay. Okay. So we can just find these probabilities here and just give you the value, and then you can just double check it yourself. 0.89886. Okay. So for question C, in which of the preceding two cases do we have higher probability of obtaining the sample estimate within 10,000? Obviously, female has higher probability. The probability for female is 98%. The probability for male is 88%. So obviously, for female is higher. And the reason why we have higher probability for female is because the standard deviation for female is obviously less than the standard deviation for male. Okay, just remember that standard deviation is the measure of variability or how different the values are from one another. So smaller probability, so smaller standard deviation for female means that the salaries of female graduates are not much different from one another. But for female, the difference between the salary for males are more different than for female. Okay, and because of the higher standard deviation for male graduates, the probability is lower. Okay. What is the probability that a simple random sample of 100 male graduates provide a sample mean more than $4,000 below the population mean? Okay, so here we have n equal to 100, obviously greater than 30. So x bar mil here is approximately normal. And then we have to find $4,000 below the population mean. Okay, so below here means that we take the population mean minus 4,000. Okay, so if we draw the graph like this, and if it's a mean, so $4,000 below the mean means that you have to go back here 4,000, and that should be this values here. You have to find the area here. So we have to find P of X bar mil smaller than mu minus 4,000. So that should give us P of Z smaller than mu minus 4,000 minus mu sigma square root of n. So that should give us P of Z smaller than minus 4,000. Sigma here is 40,000. Square root of n here is 100. So that should give us P of Z smaller than minus 1 or 0.1587. Okay. So that should give us the answer for question D. Any questions, class?
No.
Ở đây cô nhấn mạnh một chút xíu phần này nhé. Ở đây có một số bạn sẽ thắc mắc là tại sao cái câu D này nó bảo là a sample mean more than 44,000 below the population mean, thì cái từ more than này đằng ra phải là dấu lớn hơn chứ đúng không? Vậy thì ở đây cái câu hỏi này nó sẽ hơi tricky một chút xíu. Đấy là cái gọi là nó bảo rằng là cái giá trị trung bình đấy nó sẽ tức là nó sẽ nhiều hơn giá trị 4.000 nhưng lại dưới giá trị min. Thì ở đây có nghĩa là gì? Nếu cái giá trị min của chúng ta là giá trị ở giữa này và 4.000 là cái dưới giá trị min là cái giá trị mà chúng ta phải quay ngược lại như thế này, thì nhiều hơn 4.000 có nghĩa là nó sẽ phải quay về phía bên tay trái. Còn nếu mà nó rơi vào những cái khoảng ở đây chẳng hạn thì nó sẽ phải là ít hơn 4.000, đúng không nhỉ? Ở đây có thể là 3.000 này, 2.000 này, dưới giá trị min khoảng 1.000, 2.000, 3.000. Thế nhưng ở đây nó bảo nhiều hơn 4.500 giá trị min, tức là nó sẽ phải nằm ở phía bên tay trái này. 5.000, 6.000 nó sẽ phải nằm lệch về phía bên này. Và chính đó là vì sao chúng ta phải có cái dấu nhỏ hơn ở đây, không phải là dấu lớn hơn. Đấy. Thì câu này hỏi này nó hơi tricky một chút xíu, chúng ta phải để ý, nếu không thì rất là dễ là sẽ bị sai ở phần này.
Thế nếu chỗ đấy là less than thì sẽ là nằm ở giữa khoảng từ 4.000 đến min đúng không ạ?
Đúng rồi, chính xác.
Vâng ạ.
Ừ. Đấy. Right, so that is about question 5.4. Question 4.5, we'll just leave it until our next tutorial because this is the sampling distribution of proportion. So we will move to question number 6 here, which talk about the sampling distribution of X bar. As for question 7, 8, and 9, we will leave them until our next tutorial because those are the questions that are related to proportion, not the mean. Okay. All right. So for question 6 here, we have the average value of 6,000. This is, remember that this is the value for 2003, and what we have here is the question about the year 2003, not 1990. So I just write out this one in notation. Mu equal. We have a sample of 50, so n equal to 50. And you have the population standard deviation here is 2000, so sigma is equal to 2000. First, we have to show the sampling distribution of the mean. Okay. So here, remember that here in this case, we have n equal to 50 greater than 30. So according to the central limit theorem, the values of X bar, the sample mean here, is approximately normal. Right, so here, X bar is approximately normal. And when it is normal, we have to specify the mean and the standard deviation. So we say that, okay, with the mean of X equal to 6883. Remember that the mean of X here is exactly equal to the population mean. And the standard deviation of X bar is given by the formula sigma divided by the square root of n. So we have 2000 here divided by the square root of 50. Okay. So when you prove that, when you're asked to show the sampling distribution of the sample mean, you have to prove that the sample mean is actually normally distributed, and you also have to specify the average value of the sample mean and the standard deviation of the sample mean. Okay. What is the probability that the sample mean will be within 300? Okay. So we have to mu minus 300 X bar mu plus 300. So again, we have to use the formula to convert X bar into Z. So we have 300 here, 2000, 50, Z. Okay. So you can just easily, find the probability of this because we are very familiar with the way that we do this already. Okay. So this will be equal to 06Z. Okay. And then now you can just, look up the table for this value. All right. So for question C, what is the probability that the sample mean would be greater than 5,500? Okay. So that should be easy. P of x greater than 7,500. We convert it into Z. 7,500 minus 6,886. 2,000 square root of 50. So this should give us P of Z greater than 2.18. And this will be equal to 0.0146. Okay, or 1%. Okay, now so the probability that the sample mean will be greater or equal, 7,500 here is equal to 1%. So it is very, very unlikely that the sample mean will be equal to 7,500 or greater than 7,500. But if the consulting firm tells you that the sample mean for the sample that they select is actually equal to 7,500, would you question whether they follow correct simple random sampling? Then if that is the case, then it is likely we have to question whether they select the sample using the simple random sampling or not. Because if we use a simple random sampling, it is very unlikely that we will have the sample mean of 7,500 or more. But in fact, we have that situation. So it is likely that the consulting firm didn't select the sample using the simple random sampling method, but maybe they will just select it out of the convenience. So a lot of medical bills with high values are entered into the sample. So that's why we have the sample mean like this. Okay. So the probabilities here that we have 7,500 or more is very low. But if it occurs, then you have to question that, okay, maybe our sample is not random. And that's why we have the sample mean that high. Okay. All right. So that is also our last exercise to correct. So any questions, class?
Cô chỗ kia phải là 6.883 chứ ạ?
I'm sorry. Yes, my bad. Okay. So now please learn from my mistake here. Okay. Whenever you do the exercise or you do the exam, please be careful because otherwise it is very simple to make silly mistake like me. Okay, so learn from my mistake. Okay, thank you so much for correcting me.
Thôi tuần sau thi giữa kỳ thì kiểu bài cũng như thế này ạ? Kiểu short answer như này hay là trắc nghiệm ạ?
Mọi người đã được thông báo là thi giữa kỳ vào hôm nào chưa?
Chưa ạ? Chưa ạ.
Thế sao mọi người biết là tuần sau thi?
Hình như các môn khác đều
dự kiến là vào 31 cơ. Tuần sau chưa chắc là thi đâu, dự kiến là 31 tháng 3 nhé.
Vâng ạ.
Nếu tuần này mà lecture tôi còn chưa nói gì thì chứng tỏ là chưa thi đâu. Ít nhất phải thông báo trước một tuần chứ, đúng không? Nếu mà cô giáo dạy lec của em vẫn chưa thông báo là thi thì chưa thi đâu, bình tĩnh.
Vâng ạ, em cảm ơn cô.
Thi thì chắc là có thể là sẽ có cả MCQ và sẽ có cả problems. Đấy là dự kiến thì Còn mọi người sẽ đợi xem là thông báo chính thức là như thế nào nhé. Okay. Nhưng mà dự kiến là như thế. Tuần sau mọi người thi nhiều không?
Có cô ạ.
Có ạ.
Hầu như các
Thế
môn đều
thì
thi tuần sau.
thế thì may quá là môn này lại không thi vào tuần sau. Tuần này mà chưa thấy giáo viên dạy lách nói gì thì chứng tỏ là chưa thi đâu.
Vậy thì may quá.
Đương nhiên rồi, đến tuần này rồi còn chưa báo gì thì tuần sau làm sao thi được. Phải cho mọi người thông báo trước cho mọi người để mọi người biết là hôm thi hôm nào chứ. Thậm chí còn chưa biết giờ thi, lịch thi thì làm sao mà thi được. Bình tĩnh. Cô điểm danh cho Hoàng Nam nhé. Có bạn nào chưa điểm danh không? Đấy, nếu mà không có câu hỏi gì nữa thì chúng ta dừng ở đây nhé. Cảm ơn cả lớp. Đối với
Dạ
trường
cô
hợp
ạ.
đối với
Dạ
trường hợp
cô
bạn
ạ.
học bù thì cô sẽ email lại cho cô Bình nhé. Okay.
Vâng, em cảm ơn cô ạ.
Ok.
Em chào cô ạ.
Bye bye. Thank you for coming.